I just like to talk to hear myself talk. It's never very important information for any of you, so don't worry about listening to it. Any questions about the top? 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Which one?
2C.
2C.
Doesn't matter if the answer doesn't matter if that's in brackets.
No, you need that answer in brackets because those brackets group the negative as part of it.
Okay.
So this would be negative S times negative S.
Oh.
So you need those brackets. Sometimes you don't, sometimes you do. Anything else from the top of page 83? Heather? I am indeed. That's why the little red light is flashing. Nathan?
How do you get for negative 8, 9? I don't know how I messed this one up.
Which number?
Number 1. The top one on the left.
What do you do with two exponents when you are multiplying them?
I multiplied them, that's why.
Okay, Olivia. 5, yes. Remember, you don't forget any of the other math that you have learned from the 3rd grade onward. If there was nothing there, what is 36 divided by 12? 3. If there was no number there and no b there, what is a to the 4th divided by 2?
87.
What do you do with the exponents when they're the same base?
A squared.
No. Subtract a squared. And if there was nothing else there, what would you do with negative 2 and 3? Subtract them. What is negative 2 minus 3? No.
B to
No.
negative
5.
That is b to the negative 5. What there is not allowed?
negative 5.
Negative 5. So does 3a squared. The negative 5 has to go to the denominator. You are going to have a great deal of difficulty with exponents if you cannot add and subtract. I know you don't want to sit through a lesson on adding and subtracting because you are in the 10th grade. So please make sure you are aware of all the intricacies of adding and subtracting. There are the next bunch. They don't quite fit on the page, so I'm going to shrink down my view a little bit. And now they will. Yeah, because that's where we got to. Any of those? Again, do not try to write them all down. We have a busy day today in order to get you out of here at spring break with no extra homework for spring break. No questions? Which one?
K.
K. This one.
Yeah.
All right. So I have the base is the same, x and x. It's division. So I do subtraction. Negative 2 minus 4. Negative 6. So that answer is x to the negative 6. But negative exponents are not allowed because that is really x over 1 to the negative 6. So I reciprocate it and the exponent becomes positive. Nothing else? Spectacular! And now the really hard ones. These take up a lot of room. So there is the first one doesn't. The first three don't take up a lot of room. They're pretty self-explanatory. But those bottom three take up a lot of room. So the answers are that, that, and that. So, due to the oh my goshes and things, I imagine I need to go over a couple of these, which isn't a real problem. Let's start with this first one. Again, I cannot stress this enough. Do not look at the problem in its entirety. That's too much. Go at it bit by bit. So, if none of this were here, what is the base there? Negative 4pq, because they've been grouped together. And negative 4pq is cubed. So that means negative 4 is cubed, right? That 3 goes to everywhere, just like in your notes. Your notes tell you how to do the work. Negative 4 cubed is negative 4 times negative 4 times negative 4, which is negative 64. P cubed is p cubed. Q cubed is q cubed. Okay? Okay. Now, pretend none of this is there. Negative 5p cubed. Now, numbers with numbers, letters with letters, just like you learned in the 9th grade and the previous to that. 64 times 5 is 320. Negative 64 times negative 5 is positive 320. P3 and P3, are they the same base? So what do I do with the exponents? So it is p to the 6th. Are there any other q's? So it is q to the 3rd. That's it. That's your answer. In this one, she's busy. Pretend the bottom is not there. What is 4 times 6? 24. What is m to the 4th times m to the 8th? What do I do with those exponents? Add them. M to the 12th. N2, N4. N6 over. Negative 3, M6, N6. Numbers with numbers. What's 24 divided by negative 3? Negative 8. What's M12 divided by M6? M6, 12 minus 6. And what is N6 divided by N6? 1, which we don't need to write because when you multiply by 1, it doesn't change anything, does it? So it's done. And lastly, here, again, if none of this was here, what is 5 squared? 25. What is x squared squared? X to the 4th. What is y squared? Y squared. Then I've got this side. What is 3 cubed? 27. What is x squared cubed? X to the 6th, just like law number 3. And y to the 4th cubed is y to the 12th. Then, numbers with numbers. 675. Letter with letter. 4 and 6, x to the 10th. Letter with letter. 2 and 12, y to the 14th. All the laws that you already know. Nothing new except negative exponents. The only thing you have to remember with negative exponents is that exponent and its base go to the other spot in the fraction. That's it. And then, of course, these guys are all the exact same thing. Just like all math. If you can do it once, you can always do it. Just look at, pretend that's not there. What's 2 times 3? 6. X times x to the 5th, x to the 6th. Y squared times y 4, y to the 6th. Over 4, x squared, y to the 5th. Numbers with numbers. 6 over 4 becomes 3 over 2. 6 and 2, x to the 4th. 6 minus 5, y to the 1. Do I write y to the 1? No. B. Again, I do not care about the bottom right now. Is there anything happening here? No, it is negative 3p squared q to the 5th. But there is something happening here. What is negative 4 squared? 16. P squared is p squared. Q cubed squared is q to the 6th. Over, now I got to worry about the bottom, 8p4q4. Now, numbers with numbers. What's negative 3 times 16? I can't do that in my head, Mr. Myers. Fortunately, you're allowed to use your calculator. It is negative 48. What is letter with letter? P squared and p squared. P to the 4th. Letter with letter. Q5, Q6. Q11 over 8p4q4. Numbers with numbers. Negative 48 divided by 8, negative 6. P4 over P4. P to the 0, which is 1, so it's gone. Q to the 11th, Q to the 4th. Q7. Done. And then D, which I'm going to erase A so I can work right below D. Where should I start? Well, I would probably start here because there's a 3 out there. So I'm going to stop thinking about that. I'm going to stop thinking about that. And I'm just going to deal with that. What is 2 cubed? 8. X cubed, y 6th. Now I'm going to deal with the rest of the numerator. Negative 5, x4, y5. Numbers with numbers. What's negative 8 times 40? Negative 5 times 8. Negative 40. Letter with letter. X 7th. And letter with letter. Y to the 11th. Over. Now what did I have underneath? I got to deal with this, don't I? This, what is 10 squared? 100. What is x cubed squared? 6. What is y to the 8th squared? Y to the 16th. Numbers with numbers. Negative 40 over 10 becomes negative 2 over 5. 7 and 6. X to the 1. Do we write 1? No. 11 and 16. Y to the negative 5. So that isn't allowed, so it comes down there. Now here's something that may help you. I'm not sure if it will. I don't like showing it on the first couple of days of exponents because it messes kids up. What does this actually mean? There's 11 y's there, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Agreed? What does this actually mean? There's 16 y's, correct? So, it would have been. There's my 11 y's, yeah? But there are 1, 2, 3, 4, 5 more, correct? What happens to these 11? They're gone. What happens to these 11? They're gone. They're gone. They're gone. They are. And what's left there? 5 y's, which is what we had in the answer. Yes. I don't care how you think about it. I used to teach the canceling thing first, and then kids were all like, don't I just subtract? So I changed to subtracting first, and now whenever it comes out as a negative, I know what to do. I can't win, so I just show them both. Nathan.
So it just starts like, or it ends on the bottom, like in that way.
You would leave it there. All right. So, if all of you would be so kind, now that we have talked about exponents, if you would be so kind as to move to page 85. This is a very short and quick lesson. It is not particularly mathematical. It has concepts that are important in later units. So we take a moment to discuss it now. The real number system is how we count, right? That's the numbers that we use. Other cultures, other languages use different numbers, but they all follow the same concepts. If I were to ask you to all start counting with me when I clap my hands, what would be the first number you say? No, you wouldn't say 0, Malik. You would say 1. Every single one of you would say 1 automatically. That are the natural numbers. When we say natural numbers, we mean the counting numbers. And those counting numbers go from 1 up to what? Infinity. We can't ever stop. 10 is how we group our numbers. You're absolutely right, but it doesn't actually go to 10. It goes to 9. We're going to explain that in a minute. Okay? Those are the counting numbers. Now, even though they go from 1 to infinity, and infinity technically is forever, this is the smallest group of numbers that we have, even though it goes to infinity. Everyone cool with that? Well, we're getting to that too. The whole numbers is the next layer. And the whole numbers consist of the natural numbers. So the natural numbers we remember are 1 to infinity, but we add 0. So the whole numbers, when you hear whole numbers, you immediately think of fractions, right? 4 and 1/5, what's the whole number? 4. -7 and 1/5, what's the whole number? -7. But it's not really. Whole numbers are 0 to infinity. It has one more number. So it is one number bigger than this. That's why this is the smallest. I've explained that, Nathan. It goes till infinity. I agree. But this is infinity plus 1. So the next one is integers. Now, you're intelligent people. The smallest group was natural. Then the next one was the natural numbers plus a 0. So what logically are the integers? They are the whole numbers, which is 0 to infinity, plus what now? The negatives. Which means this one goes from negative infinity all the way up to what? Positive infinity. Making it, even though they're all infinite, technically making it the biggest group of those three. Everybody cool? Now, if you were to do this, draw this out like a basket, and you don't have to, but it would look like this. That would be the integers, and inside the integers can fit all the whole numbers, and inside the whole numbers can fit all the natural numbers. Everybody cool? We're getting to that. These three things are no fractions and no decimals. They aren't allowed in those three. Everybody cool? Too sharp. Sure you do. Have a good game. Good luck. Now, Nathan has asked a very astute question. What about the decimals? And he is right, because decimals are fractions, and that is where all of you got lost in math. It's true, because previous to grade 3 or 4, where you learned about decimals and fractions, you all counted with which numbers? 1, 2. You might have brought 0 to the party. Maybe. Right? And most of you probably got that discipline from your parents, where your mom said, go clean your room. And you said, okay, and you went to clean your room. But then you got a little bit older, and your mom said, go clean your room, and you went, no. And your mom said, go clean your room, and you went, no. And then your mom said, 1. And you were like, oh, what the hell is this? And you went and cleaned your room. Then you realized you got a little bit older. Your mom went 1, and you went, no. And your mom, I'm smarter than you. Your mom went 2, and you were like, what the hell? And you went and cleaned your room because you never wanted to get to 3. Because you didn't know what was going to happen at 3. Here's a hint. Neither did your mom. That's why your mom went when she got to 2 and you went, no. She went 2.5. What the hell? Where did half come from? I've never heard of half. Because of course, your mom, because all of you were born in 2004 or 3, your mom wasn't allowed to do what my mom was allowed to do when my mom got to 3. My mom didn't even bother counting. Go clean your room. No. Okay, I'm cleaning my room, I guess. My mom's counting to 3 was after she hit me 3 times and I still didn't clean my room, she went and got Dad. And Dad didn't bother even waiting for the explanation. If Dad knew he came into the room, Dad knew we were well past 1, 2, 3. So, no, my dad didn't ever have a need to use any kind of weapon. My dad's hand, for whatever reason, his whole body was made of skin and muscles, but his hand was made of solid granite. I don't know how. He was like a kind of superhero. He was like Thunder Fist. He's a bad Marvel hero that like nobody knows. He's got a DC counterpart. I can't remember his name either because he's just as lame. Lightning. No, yeah, it is. Yeah, I think it is Lightning somebody or other. I don't remember. Anyway, he's got a big, strong punch. Anyways. So that is when the decimals come into play. Now, the reason this scares you is because until grade 3, 0 and 1, there was nothing in the middle of it. You went from 0 to 1, 1 to 2, 2 to 3. Then in grade 3, your teacher said, aha, there's a half. And you were like, okay, I get a half, no problem. And then your teacher said, there's a quarter. And then you were like, yeah, okay, no problem. Money, quarters, got it. Easy, easy peasy, lemon squeezy. And then she went, there's an 1/8. And you were like, okay. And then there was a 16th. And then there was a 32nd. And then there was a 64th. And then there was a 128th. Then there was 256. Then there was a 512th. Then there was a 1024th. Then there was 2048. Then there was a 4096. And then there was an 8,000. Anyways, if I continue to cut this distance in half, will I ever get to 0? No. Which means, how far is it really from 0 to 1? Infinity. And that's why you get screwed. Because all of a sudden, those numbers that were your best buddy, because you were counting, I'm 8.5, and I'm going to be 9 in April. All of a sudden, those numbers are not your friend anymore. And all of a sudden, they are there to beat you up. Rational numbers are fractions. But they have some rules. They have to be x over y. X has to be an integer. And y has to be an integer. And y cannot equal 0. Any number that you write like this is a rational number. And those are your fractions. Your fractions lead you to your decimals because they are x divided by y. And that gets you a decimal. Now, those decimals also have to be special because they must either end or repeat. And it's a good thing we're doing it today because today is pi day, and pi is the famous irrational number that never ends or repeats. Yes. March 14th. Good to know. Of course not, because that's a useless thing to do. 3.14159, and then I'm done. That was nice of her. I'm glad Miss Chu is so much nicer than I am. They are. They are up to billions of decimals of pi. There's a computer that was started in 1960 something, about the size of this room, and its only job was to divide pi.
Why do they care?
Because what if, Nathan, eventually 20 bazillion decimal places down the line, it starts repeating? It won't matter at all, but it will matter in that we think in our universe that pi is always going to be irrational. If pi suddenly appears to be rational, that means a great many other assumptions that we have made about our universe are indeed also possibly not true. And that would be a big deal. They just keep dividing, man. It's just bring down the next number. It's long division. You bring down the remainder. That's why those people that look like they've memorized it are really just dividing really, really fast.
That's something great.
Now, irrational numbers are, of course, the numbers that don't fit anywhere else. So, pi is a famous one. We know that pi is supposed to be the circumference divided by the diameter. And you would look at that and say, oh, that's x over y. But it is not. Because one of those two is not going to be an integer. Right? One of them would have a decimal in it. That's why pi is like that. That's fine. The more important ones, the more important rational numbers that we use are these. The square root of x when it doesn't work. What? What do you mean by that? Well, what's the square root of 4? 2 works fine. What's the square root of 9? 3 works fine. What's the square root of 1? 1 works fine. What's the square root of 1 quarter? 1/2. All works fine. Everybody with me? What's the square root of 2? No. Use your calculator. What's the square root of 2? 1.414, blah, 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 blah. Your calculator screen fills up, yes? That is an irrational number. So is the square root of 3. So is the square root of 5. So is the square root of 7. So is the square root of 8. Everybody with me? Nathan? Yes. Anytime you hit square root of anything and it fills up your whole screen, it's irrational. Now, sometimes it's okay. For example, the square root of 1.44. You would think that's not a rational number, but it is. 1.2. And see how that decimal ends? So it's rational. But, 1 second, Nathan, hold that thought. Square root of 1.45, what's that? Fills up your whole screen with no repeating, so it's done. That's irrational. Now, Nathan, go.
But for the x divided by y, it has to end with a p.
Yep.
But doesn't the 1.45 end?
No.
Oh, it has like a little repeating.
It doesn't end. Try it on your calculator. Do square root of 1.45. While Nathan is doing that, Jacqueline, I will answer your question. Oh, okay. Whole screen fills up with no repeating. If your calculator screen went to infinity, how many numbers would be on that calculator screen? Infinite numbers. Would there be any repetition? No. Would there be any end? No.
Okay.
Everybody cool?
It just doesn't show you.
No, of course, it can't show it. Your calculator screen has to end. It's not an infinite calculator screen. Everybody understand? All right.
Can't the rational numbers have decimals?
Yes. If a decimal ends or repeats, it's rational. So, what is 1 divided by 2? First of all, is that an integer? Yes. Is that an integer? Yes. So this is a rational number. As a decimal, what is it? 0.5. It ends. What is 2 divided by 3? Is that an integer? Is that an integer? So this is a rational number. As a decimal, what is it? 0.666, repeating forever. It repeats. A lot of calculators round at the end to 7. But they only do that because your calculator screen runs out of room. All right, turn the page over, please. 86. You already know how to do this from your trig unit. 12 over, not 1,000.
100.
100. 12 over 100. Would you ever leave that answer that way in my class? No, of course not. What is it really? 3 over 25. Are these different values? No. They just look different because of simplification. Everybody cool? Are they all rational? Yes. Malik? Yeah, that would get you the same thing. No, not 1.2 over 10. 1.2 over 1. No. 1.2 over 10. You were right the first time. Nobody's ever asked me that. It kind of took me by surprise. All right. What is this? This means 0.11111 forever and ever and ever, yes? Now, some of you already know the trick. How do I turn that into a fraction? Who knows what it is right away because your teacher taught you the trick? Yeah. Does anybody know the trick? Oh, sweet. It's the first time ever no one's known the trick. Yes, I know, but I want it as a fraction. Because since it's a repeating decimal, I can convert it to a fraction, can't I? No. And we're going to talk about why. If that line was not there, that is 1 over 10, correct? Everyone agrees? All right. But that line is there. 1 over 10 is 0.1, yes? But that line is there. So it's 0.111111, correct? Which means, which one is bigger? 0.1 or 0.11111? This is slightly bigger, yes? So if we were to do the old hungry alligator thing, 0.1 is less than 0.11111, correct? All right. Now, 0.1 is 1/10. And that must be less than whatever this is, yes? And we know this fraction has to be a 1. What has to go there? 9. Why? Because 1/9 is the next integer that we could have in this fraction. That is 1 step bigger than 10. Even though the number is smaller, the fraction is bigger. I know. So, if you do 1 divided by 9, what do you get? On your calculator, what do you get? 0.11111111, right? So, if something happens once in math, when does it happen? All the time. So what then would 0.55 repeating be? 55 over 99. Or 5 over 9. Everybody cool? What would 17 repeating be?
17.
It would be 17 over what? 99. Because without the line, it would be 17 over 100, right? So with the line, it's 17 over 99. Everybody cool? All right. You're intelligent young people. What's that one? What does the ... mean? It means that the decimal goes further, correct? Is this the same as that line? No. The dots mean the decimal carries on. Do we know that it's going to be 2s till the end of time? No. But what is the assumption we make here? That it is 2 till the end of time. So what would this be as a fraction? 22 over 99 or 2 over 9. Everybody cool? Kind of. Look at the last one. How is that different? It's only on the 4. So, if it was over all of it, what would it be? It'd be 54 over 99. Agreed? Okay. But it's only over the 4. So, what's your guess? Your guess is 5.4 over 9? What does that get you on your calculator if you do that? 0.6, so it's not that. I like the way you're thinking. Why did you use only one 9? Oh, I see. Okay. Because you made this 5.4 and the 9 is one digit. Okay, I understand. Anybody else? Nathan? 5.4 divided by 9.4. What does that get you on your calculator? Does that get you 0.544444? No. Heather?
5.4 over 9.9.
Well, let's see what we get when we get 5.4 over 9.9. What does that give you on your calculator? 5.4 divided by 9.9. Gets you 0.545454. Oh, we're getting closer. 49 over what? 49 over 90. What's that get us? That gets us that. How did you come to that, Sam? Or was it just trial and error?
I just put in 0.54 repeating and it
turned it into a fraction with your calculator. Absolutely. Yeah, that works. The reason that it works, though, is this. How many numbers are repeating there? Just the 4. I know that every repeating number needs to have a 9, yes? But I have hundredths here, don't I? So I better put it over 90. Now, if I do 54 over 90, that didn't work, right? What part of that isn't repeating? The 5. 54 minus the 5, 49 over 90. And that's what it is. So what if I had 67.67 and just the 7 was repeating? What would it be? 67 minus 6 over 90. Done. The part that doesn't repeat is subtracted out. Heather.
Why is it just 90 and not 99?
Because when you put another 9 under there, then the 5 starts repeating. Right?
Are you getting rid of the whole 6? Or are you subtracting the 6?
You're taking the 6 out of the 67 because it's not repeating. It's just one of those weird things about numbers that works. Like all those other weird things you people have been taught about numbers. Like if the 3 digits of a number add up to a number that divides by 3, that number divides by 3. It's just a weird math thing with numbers that works. All right, your job now, and your only job right now, is to tell me which categories these 7 numbers fit into. What are your category options? Irrational, rational, integer, whole, natural. Now, if your number is natural, is it automatically everything else? Yes. Okay, go. Nope, you just got to write the smallest group in which it fits. The smallest group into which it fits. That is the cubed root of negative 14.
I don't know how to put that.
I know you don't. So you got to think about this. There is.
Because it would be on the right side.
Yes, of course it's irrational. Can you think of any three numbers that multiply together to make 14? No, because 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. What's in the middle? So it must be what? Irrational. Natural is the smallest. If it is a natural number, it is automatically whole, it is automatically an integer, it is automatically rational. You only need to write the smallest group.
How come why did for F, it said not here?
I know it did. We're going to talk about that in a minute when we get there. It's there for a reason. It is there to spark your curiosity, Nathan. Did it? Are you interested in knowing why that is not irrational?
Yeah.
Good.
I can't figure out how to do A. Because my 3 always goes behind. It's improbable.
Don't worry about it. I'll explain it all in a minute. Go on and do what you know. Satjo, what are you doing?
When there's the infinite line on top, is that like the automatically just goes off your screen?
If the screen fills up, you mean?
Rational for.
Yeah. We're going to talk about that in a minute too.
No, it's repeating it. So it's rational. It's a decimal and
We're going to talk about that in a minute too. I want you guys to write 7 answers. You might get a couple of them wrong. That's the point.
square root of 4. So they negative 6.
All right, one more minute. I don't have my timer. I left my phone in the staff room. I said one more minute, and I went to start my timer, but my phone's in the staff room. Okay. What is the square root of 25? 5. So this is 5. What is it? Natural. Because it fits in, it satisfies natural, so it fits in everything else. What about C? It is rational. Why? It ends. This is 5 and 319,754 1/millionths. Because it ends. Actually, it's a very, very little. It is a lot of digits, but it's a very small number. It's about 5 1/3. So it'll be about $5.35. Except we don't go that far down. What about D? We just did this. What is negative 2 to the 4th power? That is positive 16. So what is it? Natural. What is 9? Natural. And of course, if it is natural, it is automatically whole and an integer. Now, what happened in F? Math error. Now, some of you would say, okay, that makes it irrational, right? But no, because our calculator will do irrational ones, won't it? If we do square root of 3, our calculator gives us a number. It doesn't say math error. It gives us an irrational number. This is not an irrational number. This is what we call, and you will not have to worry about this till 3rd or 4th year university. I just wanted to put it in there. It is what we call an imaginary number. And they exist because, and I'll explain in a moment. Go for Myers. 8. Ooh. Yes. Okay. Hi. Thanks. Bye. Give me your elevator key.
Oh. No. Good call.
Someone got snitched on.
No, she has a list downstairs of who she gives it out to. She didn't get snitched on. She just didn't return it. All right. It exists. It exists, ladies and gentlemen, because there are certain applications in physics where there's no other way to explain what is happening except to do square roots of a negative number. Because there is no such thing as a square root of a negative number, is there?
So it doesn't exist.
What is negative 2 times negative 2? Positive 4. What is 2 times 2? 4. Now, we know that negative 2 times 2 would be negative 4, but this isn't a square root, is it? Because negative 2 and 2 are not the same number. Jacqueline. Of course you can. All right? What? No, you can't. Because negative 2 times negative 2 is positive 4, Malik.
What if you make it 3? Oh, wait, that's
If you mean cube roots, yes, they exist.
so it would work.
Because if this was a cubed root of negative 27, it would be negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. Now, G. Oh, it didn't come back yet? G. You don't need to see, though. It's on your page in front of you. Riley. Pardon? Right now, can we guarantee its rationality? No. But we can make the assumption that it is rational based on what? That 18181818 repeats. If this was not there, is it rational? Absolutely. If this was there, is it rational? Absolutely. But this means we can only assume that it's rational. Because who knows if at the millionth decimal place it might start going 29, 29, 29.
What is the assumption to say it's irrational?
An assumption always has the possibility of being wrong. So right now you would assume rationality based on the fact that there is repeating. Now what if it was this, Sam? What would you assume there? That you would assume irrational, because based on the knowledge that you have, that is probably not going to repeat. Cool? Everybody good?
So any chain of numbers that's repeating would be wrong.
Sure. Everybody cool? All right, now listen to me and listen to me closely. This spot is a very natural break in this unit. Because the next thing we are going to start doing is working on square roots and cube roots. Now, those are directly related to both rational and irrational numbers, and to exponents. There's a bridging lesson that normally I would give the next day after today. But I will not do that now, because if it's a bridging lesson, it's kind of useful to know where you started from, take the bridge to where you end up, yes? But that would be stupid now, because you're about to have 2 weeks off. And a great many of you forget what we did 24 hours ago, let alone 2 weeks later. So that is why I'm going to stop in this unit right now. It's a nice break. And that is why tomorrow you're writing your cumulative exam. I've explained that ad nauseum, which is Latin for until I am sick to my stomach. If you cannot or have not or will not understand what it is the cumulative is made of, you must find me and ask. Clear? For the rest of you, it means simply this. Tomorrow you will be writing an exam on both measurement and trig, our previous 2 units. If your grade improves, you get the better grade. If your grade gets worse, you keep the better grade. If you haven't written one of the previous tests, the cumulative is your only chance now to write it. If you do not write the cumulative tomorrow, and you have not written the unit test, you have 0 for that unit. Is that clear? Excellent. You have seen all manner of questions on the cumulative. You have already seen what they look like, because they are the exact same types of questions as were on your previous tests. If you have 100%, 90%, 93%, if you feel that you will gain nothing from writing the cumulative, then don't write it. But listen to me and listen to me closely. If you choose to not write a cumulative exam, you are saying to me that you do not care to improve your mark, which means when I hand back your next test, you will not come up to me and say, oh, couldn't I have a half mark here? Clear? Also, your cumulatives are your review for your final, which means if you don't write it, you don't have a review. So in June, are you allowed to come up to me and say, oh, Mr. Myers, could I just get a review package for studying or something? Because what is the answer? No, because where is that review package? It is cumulative 1, cumulative 2, and cumulative 3. Clear? Excellent. So again, tomorrow you will come to class. Now, let's say you are one of these people that just says, you know what, I don't want to write the cumulative. I'm getting an A. I don't care. I'm not going to write it. No problem. Are you allowed to not come to class? Of course not, because I am still responsible for you while you are in class. That is why we take attendance. It is not to track you down. It is so if you get hit by a bus while you are not here and you are supposed to be here, it is not my fault. Clear? Excellent. I shall expect to see all of you tomorrow to write the cumulative. If you do not, no problem. What you have on Check My Mark stays as your score on Check My Mark. Everybody clear? Excellent. Now, you have 21 minutes left in class. You have the choice of either A, doing this little bit of homework, and then you would have nothing to do over spring break, or B, I will allow you to look over your previous 2 tests in preparation for your cumulative tomorrow, and you could ask me questions about both measurement and trig. It is your time. Do with it as you see fit. Clear? Excellent. And I will see all of you tomorrow morning, the second block to write said exam. Gouda? Great. Go.